Alright, we've got a little power supply from a Phillips TV, 47-inch flat screen TV today, and it's got a problem with this transformer here. When you turn the TV on, you can hear crackling and popping and smell the magic smoke escaping. So whenever I pulled the TV apart, the first thing I noticed was that in between this capacitor and this transformer, there's a big black spot. And when we flip the board over, we'll see that this problem is obvious. Now, I don't believe that there's any component here or anything like that. I think that the trace is actually burned away. So what I would like to do here is actually remove this transformer, because I think that the transformer is fine. I really think that the root of this problem is that this board vibrates. You don't really realize it, but I mean, this whole thing, these switch mode power supplies, they do actually vibrate. And so what I think happened is that, and it could be that this trace was actually weak at first too, but I really think that that vibration made this solder joint crack, and then from that the resistance got high and the heat went up, and it just, you know, kind of started the downhill process of, there's actually a hole in that board, wow, of burning this trace out and pretty much just destroying this section of the board. Now, I think that this is going to be salvageable, and the way that we'll do that is we'll actually desolder this transformer, and we'll also desolder this cap. I believe that this is just going to be some sort of a filtering cap, but I want to desolder both of them and clean the board up, and we'll actually get in here with a Dremel and we'll try to cut some of this burned section away, because we don't want, when these boards burn, this is just, you know, pretty much like a almost fiberglass kind of material, but when they burn, they become conductive, and we don't want it to be conductive to anywhere else where it might actually cause damage. So we'll just get rid of that section. This is what looks like just a single-sided board. A lot of these TV power supplies are like that. They're just a single-sided board, which is pretty helpful for us because it makes it to where we don't really have to worry about any traces or anything on the top side. But we're gonna try to repair this thing without replacing any parts, because I don't have any parts like this. So if this transformer is toasted, we'll be in a bind. But honestly, I don't believe it is. I think that we just have to cut this section of the board out, and we'll use some of that yellow Teflon coated wire. If you haven't seen that yet, we'll look at it later, and just build a jumper from here to here and solder it in. And I'm also gonna probably, we'll see how it looks, but I may try to put some silicone or something in there to kind of squish a little bit of that vibration. I think that that is all for that transformer and that capacitor. Before we start with the desoldering gun, we'll preheat the board a little bit just to make things flow a little better. We're going to try to avoid putting heat on this area here with all these S&D components also. So it's, you know, it's a little finicky here, you know, making sure that we get heat here but not here, but it's not too bad. I've seen some people, whenever they are using these hot air guns, what they like to do is they literally move this fast on this board whenever they're preheating, and that's really not a good thing to do. I mean, think about it. I can do like this on my hand all day, and I'm never gonna warm my hand up. So you want to move you don't want to sit there and just dwell, but you also don't want to fly around like this. You want to just kind of, a nice, easy, steady movement, especially for just preheating. You really don't have to fly around, especially on these boards that are like this. These boards are not really heat sensitive. I just find it makes it a little bit easier to desolder if we do some preheat. And kind of what I'm watching out for as an indicator of when this board is the right temperature is I want that flux to just barely start to flow. And we're just getting there. There we go. Okay. Alright, I apologize if it gets noisy. I've got to turn my fume extractor on. Actually add a little bit of our own solder in there to get it to melt through that joint. Okay, so we've got the transformer out, and it really doesn't look too bad. I mean, I think if I clean up this pin here, I think we'll be okay. Everything else, all the pins look good. It's a little dusty, but, what can you really do about that? I mean, we'll scrub it as best we can, but... But I think that we'll be okay with this transformer. The board itself, well, we'll just have to get in there and probably, I'm thinking, Dremel a little bit of this out with a little Dremel cutoff wheel, and we'll also try to go ahead and pull this trace up. We'll try to get this trace up and out of here, because we don't want that trace in there just kind of flapping around. We really want to make sure that we're well bonded to the board when we do that. And where we're going to try to just leave that little bit of a pad there. Safety glasses. So I think what we'll try to do for cleaning this pad up here, this pin, is actually put a little bit of flux on it. And then we'll actually use our soldering iron and just kind of try to wick this solder away and see if we can get to some good stuff. Try to do a little bit of scraping here. We're gonna add some hot. Careful, this stuff is burning. I'm gonna add some fresh solder to this. Really what I'm trying to do is actually get the trash to kind of just draw away from that pin. And I'm doing that by more or less scraping my iron across it. Alright, now we want to check to make sure we still have continuity across this. Looks like we do 0.8, 0.9 ohms. That seems pretty reasonable to me. So I'm pretty confident in saying that this transformer is still good. Go ahead and slide it back in. Okay, so I've got the transformer back in, and you can probably see, let me see if I can zoom this in a little bit. That this leg is kind of just flopping around in the breeze, but I think that it'll be okay, at least for what we're doing. Of course, it goes without saying, if you are doing this, you do it at your own risk. Get them wrapped up and bring them around back to clear up. Get folders on. Wrapped up, ready to go for it. Alright, also, do y'all have hydraulic pressure gauges there? 5,000 psi? Yeah. If you, I don't guess it really matters for this one. The liquid feel would be better. What kind of connections do they have on those quarter MPT? Alrighty. Could you pull one of those T's and one of those gauges for me, and I'll have somebody pick them up? Alright, thank you. Bye-bye. Alright, so we've got the board all cleaned up. We've got the transformer soldered back in and the capacitor. You can see the little jumper wire that I used. And I used this, I used this Teflon coated wire here. It's a 22 gauge. It's kind of classified as a marine wire, but it's actually got tinning on it, and it can actually handle higher amperages than your normal 22 gauge wire. It's also stranded. It also solders really, really well, so it's a really good wire. And then that Teflon coating is a really high heat resistant insulator, so I don't think we'll ever have to worry about this. You know, as long as these other parts don't start cracking, which I don't think they will. Soldered them really well. But we'll get this put back in the TV, and I'll let you know if it works. Unfortunately, I don't have room for a 47-inch TV to be in my office, so I'll put it back in and I'll just report whether it works or not. So I think that's it for this repair, and thanks for watching. Alright, so just to kind of finish up this video, I reinstalled the power supply and the TV did work. But I have to give you all a word of caution, guys. This repair is not one that I recommend that anybody do. It's one of those ones that's kind of on the edge of, probably shouldn't have been done. I wasn't repairing this TV to get paid or anything like that. I don't repair these for people. I don't do this as a living. So I'm more comfortable doing very odd kind of jobs like that. But it's a very dangerous situation sometimes with these kind of power supplies, especially this power supply. I've heard reports of this thing actually catching fire. It wasn't that bad on this particular unit, but it can actually catch fire. So if you're gonna do something like this, you do so at your own risk. I once again do not recommend it. That being said, I did actually let the TV run with the back open for about 2 hours, and I was checking temperatures and looking for sparks and smelling for any smoke and things like that, and it turned out just fine. I buttoned it up and it's been working fine ever since. So once again, if you're gonna do these repairs like this, you do so at your own risk. I do it strictly to entertain people and maybe help teach them a little bit more about electronics. So by all means, if it's something you want to do, I'm not telling you not to, but don't say, oh, well, Bev said this is going to be fine, and think that it is going to be fine. You do so at your own risk. But anyways, thanks for watching. I hope you did learn a little something, and stay tuned for the next video.